Section: Introduction. In this section, we discuss recent advancements in text-to-image generation using diffusion models. These models have improved the generation of high-quality images based on text descriptions, leading to the development of open-source community models and tools. Many existing models use the CLIP model as a text encoder, which is trained on short text pairs. However, they struggle with long and complex prompts describing multiple objects with various attributes and relationships. To address these limitations, some models combine large language models, LLMs, like T5 and Llama 2 with diffusion models for better text-to-image generation. Our proposed approach, ELLA, aims to enhance prompt understanding by efficiently incorporating powerful LLMs. We introduce the time-step-aware semantic connector, TSC, to improve text alignment by extracting semantic features at different stages of image generation. ELLA's architecture includes the TSC, which adapts semantic features over time steps to enhance text-image alignment. We create a dataset called Dense Prompt Graph Benchmark, DPG Bench, to evaluate the semantic alignment capabilities of text-to-image models using lengthy and complex prompts. Our experiments show that ELLA outperforms existing models in semantic alignment and prompt-following abilities. In summary, our contributions include proposing ELLA as a lightweight approach to enhance CLIP-based diffusion models with LLMs, introducing the TSC for dynamic semantic feature extraction, and creating the DPG Bench dataset for evaluating model performance. Our results demonstrate the effectiveness of ELLA in improving text alignment and prompt-following capabilities of text-to-image models. Section Summary. In this section, we summarize recent advancements in text-to-image generation using diffusion models, which have led to the development of high-quality text-relevant images. Existing models face challenges with long, dense prompts describing multiple objects and relationships, prompting the integration of large language models, LLM, like T5 to enhance language understanding. To address these limitations, we introduce ELLA, a lightweight approach that incorporates LLM efficiently, improving text alignment and comprehension without the need for full U-Net training. Our proposed time-step-aware semantic connector, TSC, dynamically adapts semantic features from pre-trained LLM at different denoising stages, enhancing text-image alignment and enabling better comprehension of dense prompts. Section: Compositional Text-to-Image Diffusion Models. In this section, we explore various methods of compositional text-to-image diffusion models to better understand complex prompts. We have observed that some approaches focus on adjusting cross-attention maps or latent features based on spatial or semantic constraints in the prompt. However, these methods rely heavily on the interpretability of the base models and often result in limited control over image generation. To address these challenges, we propose leveraging image understanding feedback to fine-tune text-to-image models. By using feedback from image understanding, we aim to enhance the model's ability to follow prompts effectively. Additionally, we incorporate large language models, LLMs, to improve the prompt or its embedding, allowing us to break down prompts into multiple regional descriptions for guiding the image generation process. Our method enhances the base model's prompt-following capabilities and can be easily combined with training-free techniques. To effectively merge the language understanding of LLMs with the image generation potential of diffusion models, we introduce our ELLA architecture. In ELLA, we utilize a pre-trained LLM as the text encoder to provide comprehensive text features for conditioning image generation. We also introduce a time-step-aware semantic connector, TSC, to enhance semantic conditioning during the diffusion process. For dataset construction, we address the limitations of existing web datasets by generating long, detailed captions using the MLLM Cog VLM. This helps improve the correlation between images and text by providing richer semantic information. By incorporating diverse data sources and constructing a new benchmark called Dense Prompt Graph Benchmark, DPG Bench, we aim to evaluate generation models' ability to follow dense prompts effectively. Our benchmark includes longer, more informative prompts compared to existing benchmarks, ensuring a comprehensive evaluation of model performance. Section Summary. In this section, we explore compositional text-to-image diffusion models that aim to improve adherence to complex prompts. We investigate leveraging image understanding feedback to fine-tune text-to-image models and enhancing prompt deconstruction using large language models, LLMs. Our proposed ELLA architecture effectively combines LLMs as text encoders and a time-step-aware semantic connector to improve semantic conditioning during the diffusion process, ultimately enhancing prompt following capabilities. Section: Implementation Details. In this section, we utilize the encoder of T5XL, a 1.2b model, for extracting text features. To make our models more compatible with others in the open source community, we based our training on SDV 1.5 and SDXL models. We trained our models on 34 million image text pairs, using a text token length of 128 to handle complex scene understanding in dense captions. The training included 512 resolution for text alignment and further training on 100K high-quality data with 1024 resolution for aesthetic improvements. We used the Atom W optimizer with specific settings for ELLA's DV 1.5 and ELLASDXL models. The training process took around 7 days for ELLA's DV 1.5 and 14 days for ELLASDXL on 840GA100 GPUs. Our ELLASDXL model required less than 80% of the training time compared to Pixart Alpha, 753A100 GPU days. To evaluate our models, we conducted experiments on a subset of T2I comp bench to assess alignment between generated images and text conditions. Our ELLA's DV 1.5 model outperformed its base model SDV 1.5 and even matched SDXL in some evaluation categories. ELLASDXL performed better than SDXL and Pixart Alpha in most categories. We found that the MLLM caption model is sensitive to information like color and texture in images, which helps in learning these attributes. We also tested our models on dense prompts with complex information using our proposed DPG bench. Our models, ELLA's DV 1.5 and ELLASDXL, showed superior performance with fewer training parameters compared to other models. Even though they slightly trailed behind DALL-E3, they demonstrated excellent comprehension of dense prompts, capturing precise details in generated images. In addition to quantitative evaluation, we conducted a user study to assess text-image alignment and aesthetic quality. The results showed that our ELLASDXL model outperformed other open-source models in text-image alignment while maintaining comparable aesthetic quality to SDXL. Our ELLA model can be seamlessly integrated into downstream tools of Stable Diffusion, enhancing prompt following ability in community models like LoRa and ControlNet. Ablation studies were conducted to analyze the impact of different large language models and network designs on model performance. The experiments showed that the transformer-based module was more effective than MLP in transferring language model capabilities to diffusion models. Our final design for TSC, incorporating timestep with ADA-LN, performed the best on evaluation metrics, showcasing the effectiveness of our chosen network architecture.